so I don't want a preliminary answer. I want the answer when we finish this thing up. Yeah, Brittany?
1.46.
1.46, and the units are?
Grams.
Grams. Okay. Is that what other folks got? All right, good. Any questions on that one?
Can you actually do the sig fig thing again? Like,
Okay. Take it from the top. How many sigs, Nikki?
3.
3. How many sigs?
4.
4. When you are multiplying or dividing, and in chemistry we almost always do one of those. Addition and subtraction, that's a separate issue. Okay. In fact, the question on your quiz last time that I screwed up so horribly, I didn't even count that, so you got a point for nothing. I just X'd it out because there was multiple confusions. 2 lines instead of 1. Anyway, you know it was a mess. Okay, so if you're multiplying or dividing here, when we try to think about 6, Nicole, could you tell her the rule?
Use the lowest number.
Use the lowest number. You can think of that as the strength of a chain is only as strong as its weakest link. The weakest link dictates the strength of the entire chain. And so, this is your weak link. So we go with 3. So that's why your calculator may run a whole bunch of other stuff out here, but we want to round. Okay? That was all there was to section 11, just a little review of percentage stuff. Now let's move into 12, density. When we talk about density, we define density mass per unit volume. And we usually just go to here, like so. Okay, in your laboratory, you were finding the density of several different things. You had water. I hope you used distilled water because our tap water would probably give a slightly different answer. And you found the mass of the water, and you found the volume of the water, and all you had to put it in is in this equation, and you solved, you thought about sig figs, and you thought about units. Okay, other things we're going to do with this. When you look at this, and this is a need to know, if you like flashcards, this might be one of the things you'd have on a flashcard. Density is mass per unit volume. If I say the density of copper is 8.9, I'm just making that up. It's in that neighborhood. The density of copper is 8.9 grams per milliliter. Okay, Liz, is that a physical or chemical property?
The density, chemical.
Did you, okay, the stuff that you used in the laboratory, like those cylinders, did you destroy my cylinders?
Okay, no.
No. So it's non-destructive. You take the measurement of the mass, the volume, you haven't destroyed the stuff. Okay, so density is a physical property. Now, we have in this 1, 2, 3 variables. In real life, what you need to be able to do is, okay, if you're given this one and this one, no sweat. You know this, stick them in, do it. Okay, but it gets harder in real life. In a real lab, sometimes you know the density and you know the mass. You got to solve for what volume of this stuff to pour out if it's a liquid. So you should be able to use your algebra skills and solve for each one of these. Okay, I had a student one semester, she couldn't do algebra at all. She memorized 3 different equations. Oh, don't, please, don't clutter your brains like that. Okay, if your algebra skills, you know, moving stuff around aren't there, get them there. And we'll do 1 or 2 slowly today, and then I'm going to assume everybody caught on and can do it. So let's take first problem. It's problem 1-13. Okay, this is the way it looks like in Blackboard, but I would highly recommend, again, you know, I've said this, but I say it again and again, because repetition, it sticks in your brain. Okay, we're going to work this problem together. Later this afternoon, then go back, take another look at it, use your notes if you have to. Okay, and then wait a day or two, give it some time to digest, And then just take it just like that with no notes inside, no equations inside, and just do it. But I wouldn't do it from Blackboard. I would look in the textbook and see if they give you a whole bunch of extra stuff, you know, where you have to sort through. Because I just write the minimum, type the minimum here. So they may have told you 2 or 3 sentences about what is ethyl alcohol. And you got to sort through, that's garbage. You don't need that to solve the problem. So you've got to have the skill of pulling the guts out of it, what you really need in all the fluff that could be in there. Like ethyl alcohol. It's also called ethanol. Here's kind of an interesting story. In academic chemistry, we call it ethanol, OL, because that ending, if a chemist hears the ending OL, it means alcohol. That's it, because we have our own special language. But in industry, not everybody that's working with this stuff is a chemist. And so they don't know OL means alcohol. You know, like ose, sucrose, glucose means sugar. Okay, it's a language. Ethyl alcohol, so then industry workers know, that's an alcohol. Let me steal some and go drink it tonight. But not all alcohols are created equal. This is the drinking variety. Okay? It's interesting. This one has 2 carbons in it. If you get the alcohol that has 1 carbon in it, methanol, that will kill you. So if you think you're going to drink some other alcohol and drink some methanol, okay, you either go blind or you die. And I've seen, when I worked in pathology, I saw autopsy reports of guys that, trustees at the state penitentiary, that stole out of the printing lab, stole a little methanol, had a little party on the weekend, 2 were dead and 1 was blind. So, not good stuff. This stuff kills you, it just takes a whole lot longer. So it's got the 2 carbons. It depends how we metabolize it. With the 1 carbon in it, it metabolizes to formaldehyde. You've been in a biology class? That's what they use to preserve tissue, stinks. You're preserving your liver from the inside out really fast, and it's going to kill you. Okay, now, let's get over here to this problem. When you see this problem, or any problem for that matter, you want to look for the big clue. Well, the big clue is density. As soon as you see that big clue in the problem, circle it, especially test stage, circle it, and say, all right, I know it's that. So you see the big clue, you write down your equation, then you start searching. What did they give you this time? Okay, well, let's see. I see mass up there. So that's going to be 37.32, carry those units, grams. All right, then I see volume over here, 47.3 milliliters. So all we have to do is divide, and in problem, let's see, lab 7, there are some problems like this about the units. Here, no units cancel. So our final answer is going to be grams per milliliter because nothing canceled. Okay, so let's divide that through. Do it on your calculators. Everybody, do it on your calculators. And let's see what we're coming up with here. Pedro, what'd you get?
0.789.
Okay, now, clean it for sig figs. 27?
The 0.789.
Oh, I was going to say, I don't think so. Okay, 0.789.
Grams per milliliter.
Very good. Grams per milliliter. Pedro, how many sigs are in this answer?
3.
3. Why 3?
Because the 47.3 only has 360.
Okay, that's 3. How about the 0? Why isn't that significant?
Doesn't, because it's a leading 0.
It's a leading 0, and they never count no matter if you've got a decimal or not. So that's our density of ethanol.